Welcome to Flip Lesson 41 as we are looking at using formulas in the distributive property. And so to start, we're going to kind of do just a really quick review of some basic formulas that you know already. The first one being area. And what we're going to do with these then as we progress through this lesson is we're going to understand how these help us to work with what's known as the distributive property. All right. So basically, distributive property is something you know already. You just have never really seen it called that before. All right, let's start with our formula. Area equals LW, and you know that L stands for length and W stands for width. So to solve this, right, you understand that when two variables are next to each other, two letters next to each other, that means you multiply. And so we're going to take 8 and multiply by 4. And get an answer of 32, just like we're taking the feet and multiplying by feet. So feet times feet equals feet squared, right? And so we get an answer, an area of 32 feet squared. So being able to use that formula is not difficult. Now, a similar formula that goes along with rectangles is the perimeter. Now, in the past, we've looked at perimeter in different ways, right? Sometimes we look at it and say, okay, just add the 4 sides together. So we'd say side 1 plus side 2 plus side 3 plus side 4. And so we have all these different sides, add them together. And that's the basic principles. But you know that rectangles and squares, in particular rectangles, 2 of the sides are the same. So side 1 and side 3 are going to be the same, just like side 2 and side 4 are going to be the same. And so we go with these ideas, right? Length and width. And so in the past, we've looked at 2L plus 2W as an example. So 2 times the length and 2 times the width was another possibility. Today, we want to look at it in this new fashion. Perimeter equals 2 times the length plus the width. And this is really where we get the principle of what's known as distributing things. So if I plug things into this formula, we start to see that, okay, 8 is my length, 4 is my width, 4 plus 8 equals 12. 12 times 2 gives me 24. And centimeters is it, so 24 centimeters. And I could double check that work. 8 plus 8 is 16. 4 plus 4 is 8. 16 plus 8 is 24. Right? But here we suddenly come to kind of a revelation. What did we actually do here? Right? And it really works with understanding how we went from this principle to this principle to this principle and why these two are so closely related. And it's due to what's known as the distributive property. And it happens to deal with when you have a situation similar to this, when you have a number outside of the parentheses, and then you have 2 numbers inside of the parentheses that are being added or subtracted. And in the end, we end up distributing this 2 to both parts, right? To the L, to the W, right? Let's take a look at this to understand exactly what is happening here. So we have these 2 ideas, right? Perimeter equals 2 times L, and now it says plus 2, right? Distributive property says, okay, let's take this 2. And if we want to solve this, we're going to first multiply by our first factor inside our problem. And then we're going to take this 2 and we're going to multiply by the second factor. So in essence, our symbol in between, for the most part, is going to be very similar. You're going to stay the same. When we start getting into negative numbers, we're going to talk about how that changes it, but that's just because you got to take an extra step to deal with that negative number first. But instead of getting too far ahead of ourselves, right? 2 times L. Well, 2 times L is 2L. That's all it is. I'm going to make this a little fancier so you don't confuse it as 21. 2L. All right? It's 2 times L. We don't know what L is, so it stays 2L. Right? Now the second idea, right? Here, 2 times 2 equals 4. And so we distributed this 2 to the parentheses, and we got 2L plus 4. And we have this idea. All right? It's very, very similar to what we did earlier in our previous example when we had 2L plus W. Right? That was our perimeter formula. And in the end, we really came away with a problem that looked more like this. 2 times L plus 2 times W. That's what distributing things is all about. It's taking what's outside the parentheses, applying it to both pieces, not just to one piece, and then coming up with a new equation that usually has a tendency to be easier to solve. All right? All right, so let's apply this principle. All right? We can solve this problem in one of two different ways. First way, following order of operation is going to say do what's inside the parentheses, and then do what's outside of the parentheses. So if I take this, I'm going to move it over here, and inside parentheses, that's going to be 30 plus 5, so that's 35. So now my new problem is 6 times 35. And so 6 times 35, I can solve that, and I'm going to show you all my work. And we got an answer of 210. Now, how can we use this using this new principle called the distributive property? Right? So that's going to be 6 times 30, like this. So I'm going to distribute the 6 first to this idea. So 6 times 30. So 6 times 30 is 180. Right? 6 times 3 is 18, add the 0. Right? And then I'm going to distribute it to this. So I'm going to add my plus sign in there. Hasn't gone away. 6 times 5 is 30. And now I have this as my next step, 180 plus 30, which equals 210. And so in this method, I followed the normal order of operation, do what's inside the parentheses, and then do what's outside the parentheses. Here I distributed 2 within the parentheses, and then finished with addition to be able to solve the problem. Right? And both have their advantages, and that's what we're trying to figure out and learn. So first we want to learn how to work with it, then we're going to start to see how everything works. All right. Now this last idea is called solve and justify. All right. So justify, it doesn't just mean be done, give an answer, but it also means to prove it or explain why you were able to do what you just did. All right. So let's take a look at this problem and start working with this. All right, first of all, we have a couple of different ideas. First of all, we have a parentheses. Now, normal order of operations says do what's in parentheses first. However, we have a variable. All right, so if we have a variable in there, can we really do anything to that idea? And the answer is no, we can't. All right. Another thing here is this 2 is really saying 2 times that parentheses. So I can't take this 3 and add it to that 2 because that's not really how the problem works together. So I need to start by working through these steps by using my understanding of the problem, and from there I can then kind of distribute and then solve. All right. So normally with justification we start with the original equation. So I'm going to get rid of all my green that I put in there. Right, the explanation, and we would say, okay, our justification for our first step is given. That's what's given to us. All right, that's problem. Okay, so what's our next step? Our next step is going to look like this, right? I'm just going to throw the answer up there. Now ponder it. What did I actually do? What I actually did was I used the distributive property. And that's my justification. All right. So I took 2 times the 4, that's where the 8 came from. And then I took 2 times the n, that's where the 2n came from. And because the 3 is not inside the parentheses, I left the 3 alone and went straight down. But now I have a new problem. I have this idea, 8 plus 2n plus 3. Right? Okay, here's my next step. See if you can figure out what I'm doing here. All right, hopefully as you're seeing this, you're noticing that we're doing what's called the commutative property. Right? Commutative property says I can rearrange addition and multiplication problems in any order that works. Right? And so this would be technically be commutative property of addition because it is addition problem for the most part with the addition signs here. Right? So the next step, right, to actually solve this, I would actually be doing something like this, right, where I'm going to choose to add these two together. And by doing that, that's actually what's known as the associative property. And I'm sure all these terms are just flooding your mind and you're saying, oh yeah, I know all these terms, but now you're going to have to apply them. All right. Associative property, right? The key word here. So this is commutative is all about arranging it. This is about the grouping, right? Associative property is all about grouping. And then finally, I kind of come away with this idea, right? My final step is going to be this. And my justification is, basically I could say I solved it, all right? Or I could say what type of solving I did, right? I used addition. And so we come away with that idea. Or sometimes in your justification you actually just do what you did, right? 8 plus 3 equals 11. Because in the end, this is our final answer, right? There's no equal, there's nothing here, there's nothing else that we can really do to solve this problem. And we're left with an equation, which is okay, all right? We're getting to a point of math where we're not always going to come out with a solid one number answer. Instead, we might come out with something similar to this, okay? So justifying our steps, why did we do what we were able to do, right? Why did we do what we were able to do? Okay. Oh man, I stole your sample. I'm sure you're not crying too hard right now. All right, that's the end of the lesson. We'll talk more about this distributive property in class. Until then.